have your class to learn from. You have me to learn from. And I can simplify some of the stuff in the math book, okay? Are we on 11 and 12? 9.1B worksheet? 9.1B worksheet? Okay. What do the words say? Who's someone you can hear my voice, it's awful, it's horrible. I need to stop. Who's someone who's like, I don't mind reading out loud just for a little bit? Andrew Bosch. I'm going to have you read this, and then Caleb, I'm going to have you read that. Andrew, go.
If the radical is not alone in the denominator.
Okay, pause. Do you guys see that it's not alone? What's the radical? Everyone show me with your finger real quick. What's the radical? Who is that? Okay, I see Dan. Do a finger. Use the 28. Yeah, Levi's trying. It's just the square root. That's it. It's just the square root. Okay? If the radical, the square root, is not alone, what else is there? What else is there? Okay, Kayla, keep going.
We need to rationalize by multiplying by 1 creatively using the conjugate.
Okay, these are big terms. I know. But radical, you already got it? If I ever am afraid of you guys in vocab, I put little things. Radical, there we go. We need to rationalize. Okay, this is kind of weird, but that's where we multiply top and bottom by some. You guys saw us do that yesterday, right?
Yeah.
Top and bottom, a little baby square root guy. By using the conjugate. Oh, okay, this one's a little harder. Ready? The conjugate is the A minus B for the A plus B. No, that's weird. I know. Get it down. Get it down. It's the A minus B for the A plus B. Or it's the A plus B for the A minus B. Nice thing is you can talk to any kid in a higher math and you'll be like, I learned a conjugate today. They'll be like, oh, cool, that's a thing. Like, it's just somewhat common to them. Somewhat common to them. Somewhat common to them. Doesn't mean they'll know it off the top of their heads, but if you're like, oh yeah, we learned about radicals, any kid in a higher math, oh yeah, square root guys, got it. We learned about rationalizing, oh yeah, multiplying by top and bottom, got it. They're used to the vocabulary, you're still learning it, that's okay. That's okay. We're building the tools. Now, look down here, okay? I want you guys to go ahead and make little stars by those denominators. They're the problems. They're the guys that we have to fix. Simplest form of anything with a radical needs no fractions under radicals, no numbers that can be broken down with any of these perfect squares or cubes that can be pulled out, and no radicals in the denominator. So right now, not good. But what do? Well, can you guys kind of just look with me up here and say, okay, to get rid of this, I need to do this with this. Does anybody have an idea as to what, just with those clues, to get rid of that, I need to do this, but with this? It might be way too hard of a question, but maybe not. Does anybody have any idea what I'm going to multiply top and bottom? Andrew, what do you think?
Like the same thing?
Almost the same thing. The same thing as my problem, but. And what's, yeah, good. I hadn't even really taught you what a conjugate is. Good. Good. You multiply top and bottom by the same thing, that little problem guy, that little radical guy. Same thing, top and bottom, but conjugate means you flip the sign. Now, can you guys look at the examples earlier on yesterday? Were we multiplying top and bottom by the problem guy, by the radical in the denominator? You see it, right? So we're still doing that. We're saying, hey, you're the issue, denominator. We have to help you. We have to fix you. We have to simplify. It's not really fixing, it's just simplifying. He's the guy that we have the issue with, so we multiply top and bottom by him. So what's new is we're not just multiplying by this. It's harder, it's longer, we need the conjugate. So then can you guys, just take a second. What do you think we're going to be multiplying number 12 by? Go ahead, write it down. What do you think we're going to be multiplying number 12 by? Get number 12, get number 12. You can go back to the video if you need it. Or guys, I also post the PDFs of notes in Google Classroom, right? And the PDF of the notes has these filled out also. You might not even need to go to YouTube for it. Okay, come on. You got it. Right? What's on top? I'm not worried about the root 3 because he was on the numerator and I don't mind them in the numerator. I just mind them in the denominator. Caleb.
So for number 11, like the 3 doesn't matter, you don't want anything to consider?
He's not something for me to worry about.
Okay, so
Not that we're supposed to worry about. Yeah, just the bottom. Just the bottom. I'm on it.
What if they're both like on top and on bottom? Like they're both.
That's a great question, and it could sometimes happen. But I just need you to remember that if we're simplifying radicals or expressions with radicals, we're only worried about breaking down big numbers, top or bottom, and then anything stuck in the bottom. We don't need to worry about stuff stuck in the top.
Then, why does it become like the opposite?
Oh, well, actually, yeah, that's a great question because I haven't shown you what happens next. Let me show you what happens next, and then maybe I can show you going back why we had to flip the sign. So we're not done yet because we still, well, actually, if any of you guys are looking at this, a lot of you are like, well, that looks a whole lot worse than it did a second ago. And I understand that. Except, can we review something about conjugates? I didn't even call them conjugates way back in the day. Way back in the day, it was last semester. But do you guys remember at all what happened when we multiplied what we now know to be called conjugates? Yeah, if we FOIL, do you remember anything special that happened if we multiplied like an x minus 2 times an x plus 2 or an x plus 2 times an x minus 2? Anytime we FOIL what we now know are called conjugates? Yeah, we could put it in a box. Some of you also do the arrows. My question is, does anything special happen? We have, A, B, B. We have a plus and we have a minus. Okay, so a squared minus AB plus AB minus B squared. Oh, wait. What does plus AB and minus AB do when we add them together? They cancel out. Well, then, hold on. This one's going to be A minus B and A plus B. So A squared plus AB minus B squared. That also cancels out. So I'm used to having to write down all these different things from FOIL, but right now I can just write down A squared. I wonder if this property of conjugates, so Armando, you were asking why switch the sign. I'm saying switching the sign is called a conjugate. This is what happens when we multiply conjugates. We have to multiply these guys, right? I'm going to zoom back in. We have to multiply them, but what's going to happen when we do multiply them, using that idea of conjugates, is in that denominator, well, we could do our FOILing. We would get 16. Outer would be minus 4 root 2. Inner would be plus 4 root 2. Remember, if someone doesn't have a radical, they have to stay separate than the guy under the radical. It's like someone outside prison versus someone inside prison. They can be next to, but they can't actually join in together. And then we have 2 times 2 is 4, square root of 4. They're both square roots, so that's okay. They can come together. But do you guys see this canceling out with the FOILing? You might be like, well, what was the point? I still have a square root. Wait. It was square root 2 that I don't know. But since I just multiplied it by itself, and since the conjugate let me get rid of all these extra guys, don't I know him now? What is the square root of 4?
2.
Oh, I can actually make the denominator a nice number like I need it to be. Now we still have this thing up here in the numerator where we have to actually multiply. That's a good old-fashioned rainbow, a good old-fashioned distribute. But if you notice in that denominator, we've just gotten rid of that square root. Because what's 16 minus 2? 14. So I have that 12 minus 3 root 2. If any of you want to be super snazzy, maybe you would have left it in this factored form with the 3 outside. That's also okay. But we've just simplified. We've just rationalized. To be honest, one of the hardest types to rationalize. Even Algebra 2 and pre-cal kids need reminders on this one. So we're just getting a peek at 2 harder problems at the very end of our worksheet, seeing if we can kind of understand them so that when they come back and when they're really important, we might be able to remember them. They're going to come back when we talk about, or when you learn about, something called imaginary numbers in pre-calculus. When you're simplifying imaginary numbers, it kind of has to do with electricity, because imaginary numbers 1 second are imaginary, not there. And then the next second, if you square it, they're real. They are there. And then they're not there. And then they are there. There are numbers that are sometimes imaginary and sometimes real. Kind of like electricity and currents. Electricity, sometimes the current is on or the current is off. Or maybe kind of like computer programming, ones and zeros. 1 is kind of like a flip on and 0 is like a flip off. Anyway, crazy stuff. And maybe you're like, whatever. But this will come back one day, and I'm just hoping by us seeing it now that when it comes back, you're like, oh, I've seen that before. Just remind me, and then I'll be able to do it, which is a good life skill. To learn something and to kind of learn it to the extent of if I ever needed it again, I could go back and review real fast and be able to use it. I think I saw a hand somewhere. Andrew, you had a question? As I answer Andrew's question, can you guys try to do the same exact process with the number 12? Can you multiply the top and the bottom? And if you multiply correctly, can you get that nice number? It's not going to be 14, I don't think. That nice number in the denominator stands, or that means without a square root. Andrew, this one? I didn't use the box. Like I did do the box process. I just didn't show it. I did the good old-fashioned first, outer, inner, last, the smiley face version. But remember, the box version works too. I just didn't show it this time. So you could have done your 4 plus root 2. Oh, I didn't get it. And 4 minus root 2. You would have had your 16 and your plus 4 root 2 and your minus a negative. And then a positive times a negative is a negative, and square root of 2 times square root of 2 is square root of 4. So some people do that foiling without the table, and so that's the way I did it in my head, because I like going straight across. But the box helps organize, and some people would rather do that. But the nice thing is, if you notice, well, maybe when we do the next one, there is that shortcut whenever you're multiplying conjugates where you might not have to do the box. Because what ends up happening is you get the first guy squared, 16, minus the last guy squared, which is root 4. And that's what we were showing, that there is that difference of squares shortcut, that every time, without even doing the table, some people get to the point where they can say, oh, I know, your conjugates, I get it, it's going to be first guy squared minus second guy squared. So there is a shortcut for doing the table or the foiling. Max. Oh, Isaiah, sorry. Yeah, don't get lost, okay? Max. Oh, I keep on seeing Armando and Max. I just see the hand, and so I just see it's you. Armando, what's up?
Did you get 12 over 3?
Oh, I distributed, because in fractions you multiply across. So I multiplied the conjugates, and then I multiplied the numerator also, which needed that distribution here. So 3 times 4 was 12, and then 3 times root 2 is 3 root 2. So we can do that over here too, right? Because I need to distribute that root 3. Did you guys get your numerator? What does this become? Is it 5 root 3 or is it root 15?
15. 5.
Yeah. Check it. You can only bring someone under the radical if he's under the radical as well. See, and now, yeah, I know root 15 was going to be the common mistake. Do you see how 5 doesn't have a radical? So therefore, he actually gets written in front because he's not the same type. Or he's not in the same condition, maybe I should say. So it's kind of like 1 root 3 times 5 would be 5 root 3, but would you have been correct if you had written root 6 for the next one? Yes. Because the 2 is under the square root and the 3 is under the square root. We're reviewing all kinds of radical properties. Yeah, and
So how do you decide which number goes in first? Where does it find?
Oh, do you know how usually when we're doing variables in algebra, if you were to write something like this, hopefully you would write it like 2x, because that looks really confusing. We're used to the number being in front. It's kind of similar with this, because if you were to write the root 3 times 5, like, that looks confusing. Did you just not write your square root long enough? Is it supposed to be a 15? If we write it in front, it's super clear who has the 1/2 power or the radical and who doesn't. So we always write the one without the radical in front because it's much clearer. Does that make sense?
Yeah.
Okay. Now as we come down below, did anybody do the shortcut of the bottom one? Levi, if you did the shortcut, what'd you end up writing?
25 minus 2.
Good. I'm going to actually do root 2 squared or root 4, but Levi was like, oh, but I know what's going to happen. If I square a square root, it's just going to become 2. So he was actually very proper in going all the way and saying 25 minus 2. But you could have also done 25 minus root 2 squared, which is the square root, and the square is going to cancel out. Melanie, I saw your hand. I'm coming. Or you could have done that square root of 4, which becomes 2. But yeah, that's what's going to happen if you do the table, Andrew, or if you do the arrows for foiling, because the outer and inner is going to cancel, like a squared minus b squared. And that's going to be a nice number in just a second. Melanie, what's up, kiddo?
Can you explain, like, even for 11, like, how you got the numerator parts for them?
Not here, because we're supposed to keep it the same, but here, right?
Yeah.
Okay. Well, first of all, when I multiply by 1 creatively or when I rationalize, I'm always multiplying the same thing top bottom. So that's just something that has to be true. And if you look at the rest of your worksheet, because only when we multiply by 1 will something stay the same. So I need what's on top and bottoms to be the exact same so I don't throw off the balance. So they have to be the exact same top and bottom so I don't throw off the balance. And then fractions multiply straight across. So I'm doing the conjugates, a plus b, a minus b, or a minus b, a plus b. I'm doing the conjugates with like foiling or tables or shortcuts. But in the numerators, it's only a single, right now anyway, there's only a single term out here that's being multiplied, so I can do the good old-fashioned distributing in. Does that make sense?
Yeah.
And then if they're both under a square root, if they're both under a square root, they can join forces. But if one's outside, one's inside, they can still get multiplied. I'm just going to put that non-square root in front and the square root in front. Does that make sense? Okay. Yeah, Kayla. And Jonathan, I see.
First one, when you're doing, I see the part. Okay. So when you got 5, and then the square root, and then 3, what did you multiply by 3?
Nothing, because the 5 didn't have any square root pieces, so there was nothing to change the 3. So this is kind of like an x in a way. He's a separate type of number than the 5, so I just end up writing them next to each other. Like I would do a 5x, it's a 5 root 3. I'm not totally done, but I'm so close because did any of you guys get 23 to be that number, that denominator? 25 minus 2. And then we have up top the 5 root 3 plus root 6. And maybe just a couple of you, which, I mean, we're not super advanced in factoring yet, but maybe you'd be like, can't I do something with? And I can't. This is like an x, this is like a y. They're two different types of terms, a radical 3 and a radical 6. I can't do anything there. All right, we've gotten numbers 11 and 12 in some way, shape, or form done. So that should help you finish up last night's homework if for any reason. I don't know exactly where it would have happened. Not here at the beginning. I think it was a little bit later on in homework. 55 and 57. It would have happened a little bit later. But we have section 9.13 to peek at. If I can find it. Now, the nice thing is this compared to all the other ones, this one's short. If you guys look at the homework, this homework's kind of short too. If you want, as soon as you get the worksheet, can't you write down the homework or the worksheet? If any of you guys haven't done that and you've gotten behind, why don't you look at the backboard and write down the homework or the worksheet? That way you have it all ready to go. Yeah, Jerry. Yeah. The one where you're doing 11 and 12. Guys, give me 1 second. I went a little too fast. And then you need me to probably scroll down, right, bud? If anybody else needs 11 or 12, here it is on the screen. Anybody else needs 11 or 12, here it is on the screen. But for the rest of you guys, you can be writing down homework from the side. You can be writing down homework from the side. Is anybody I'm just curious, is anybody using the blank space on the back to do your homework? A couple? Okay. You don't have to, but you can. That could be a great way of staying organized. Have your worksheet on one side, homework on the other side. I personally like lines a lot better, and I like homework spirals where it's all in one place and I don't get lost. So I wouldn't like it, but I'm not saying you can't. Just a few of you, if that helps you stay organized, hey, I get it. It's hard to be organized sometimes. Okay. And then for some of you, you might want to start stapling like A and B or A and B and C worksheets together. That way you can keep it by section. Okay, Jerry, we good?
Yeah.
Okay, anybody else still working on 11 or 12? Oh, you need one more? Oh, sorry. Thanks, Danny. Because you were up and I said yes, back. We're just going to go straight here. There was like a warm-up slide, but let's just skip that. You guys got that. Thank you. Okay, operations with radicals. I just said something a second ago that provides the key for all of today's lesson. I just said something a second ago that kind of provides the key for all of today's lesson. I said square root of 3 and square root of 6 in number 12, if you still have that close. If you still have that close for number 12, I said square root of 3 and square root of 6 are not like terms. If they're not like terms, can I combine them? No. If they were like terms, could I combine them? Okay, so maybe this will be so easy until it gets hard. But maybe number 1 is so easy. My question is, are there any like terms we can combine? Yeah. How many? 2 or 3?
2.
There are 2 different like terms because there are 2 that have the exact same, who am I looking at for terms? Radicals. I'm looking for the same radicals. If they have the same radical with the same number, even like Keela, how I just said the radical is kind of like an x. Radical 2 is kind of like an x, but radical 6 would be something different. It'd be a y or a z or an a or a b or something different. But the cool thing is, oh my goodness, is it really as easy as, is anybody thinking that? If they're like terms, what can I do? Combine them. And what are they going to combine to be? I'm going to have 13 of those root 2's, and then minus root 6. Dun, 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 dun.
Oh, wow.
Now, look at the rest of the page. Do any of the other ones look that easy?
No.
Okay, so it gets harder. But this is the main concept. What's the main concept like? You can combine when the radicals have the same number underneath, right? Now technically it has to be the same type of radical too. You can't combine like a square root with a cubed root. Those are not like terms either. But I need to have the exact same radical, so square root, and the exact same number underneath. And I can just say 3 of them, 10 of them, 13 of them. No big deal. Done. But what's different when we get to something like number 2? Uh-oh. You know what? Let's not do number 2 yet. Just kidding. Can you guys go down to 1 and 2? Number 2 is it? It's all right. It's all right. It's all right. Look down. Look down. Look down. Not across. Look down. Aren't these ones just adding and subtracting also?
Yeah.
But what's wrong?
No, you can't combine like terms.
None of them are like yet. They're not like yet. Armando, you asked me a second ago, and I don't remember what the question was that you asked, but I answered by saying, okay, remember, we can't have fractions in radicals. We can't have radicals in denominators, but what was the very first thing for simplest form that we had to look out for? Big numbers that needed to be, well, simplified, broken down, factored out. Do we have any big numbers that could be? Did anybody see that before I got there? 63 is a big number. I I think stuff goes into 63. What goes into 63?
7.
7 times.
9.
So what can I do to 63?
You can number 9.
I can make it a 7 because what's radical 9?
1, 2,
3 and 3. 3 squared. Square root of 9 is 3. So can't I change 63 to be 3 rad 7?
Yeah.
Or 3 square root 7? Rad is radical. Now hold on, wait a minute. Isn't this 63 just one part of that term?
Yeah.
Okay, so hold on, let's go over here. Let's take what we saw by breaking down 63. I have 4 radical 7 minus 6 times. I need to do a substitution. Does that make sense? I took just the radical 63, I broke him down and said, I know you're 3, but 3 without a radical. Square root of 9 equals 3, just 3, so he goes in front. So I'm going to substitute for root 63, 3 radical 7. Good so far? Now they're like, well, they're kind of like terms. Hold on, PEMDAS. What should I probably do before I subtract?
Multiply.
Okay, multiply. So I have 6 of those radical 63s, or 6 of those 3 root 7s, which means I actually have 18 of them, right? But now what can you do? Combine those like terms. Now pause and ponder. Is it making sense? I couldn't combine, but I could break down. And when I broke down, with a quick little, 6 of those, cool, there's 18. Now, careful, the 6 is outside the radical. He only multiplied or combined with numbers outside the radical. He didn't get to get multiplied by the 7, just the 3. There's 18 of those. Sweet. What's 4 minus 18, guys?
14.
I have negative 14 of those radical 7s. Dun, 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 dun. Does that make sense?
We divide.
Would you ever divide them?
We can divide all of them.
Well, it's a good idea we can divide all of them by 7, but I'm going to use, instead of dividing, factoring and breaking down. So yes, we are going to think about all of them. So Andrew's already looking at number 2 saying like, wait, I saw that we were able to get to 7s. So he's hoping we can get them all to 7s. So guys, hold on. Can we take the rad 14 and break him down?
2, 7.
Now is that good or is that bad? Why is it bad? I can break it down. The 2 would just be 1 and 2, 1 and 7. My question is, are either of these perfect squares that we can solve? No. So the bummer is, I was able to break him down, but I can't take either of those square roots. I could take the square root of 9, and that was perfect. But I can't do, I think he might just be stuck. The same way that 7 is stuck. But guys, look up at example number 1. Wasn't root 6 also stuck and we didn't get to do anything with him? Root 2 was stuck, root 6 was stuck. But wait. Andrew noticed we can also try to break down root 28 though, right? What does root 28 become? 2 and 14. 4. 7 and 4. Why is 7 and 4 way better? 4 can be square rooted. What is the square root of 4? 2. So can't I rewrite? Now careful. There's a plus 2 times, right?
2.
Now, what's square root of 28? 2 rad 7. Remember, I'm substituting in. I'm able to substitute. I'm able to change. The root 14, I couldn't do anything, so I just had to leave him. But the root 28, I was able to say is 2 rad 7. Now, it might not be able to make everybody mush together, but can I at least do some? The answer is yes. So I have 3 root 7 minus 5 root 14 plus 4 root 7. I can combine some like terms, right?
7.
Got it. 7 root 7. And Andrew, even though what you saw was good, like let's try to get everybody down to 7 to 14. He just couldn't go down anymore. He's not big enough. He couldn't be broken down. Well, does that make sense? Now guys, check out your worksheets. I know some people get out early sometimes. It messes up those of us that need to use the rest of class. But what didn't we do on this worksheet?
Combine
Number 2 or number 3, right? So I'm not going to be able to do number 3. I just want to give you a peek at number 2 just for a hint. As we have like 55 seconds. Okay? Number 2, I just want to show you a hint. When we have now, if we can add, we'll add. So maybe some of you would try taking this root 32, and you might try breaking him down to see if root 32 could be anything good. And actually, oh yeah, he is. He's nice. He's real nice. But if you didn't see that, it actually wouldn't have been illegal to do this either and then try to break down. Just remember when you multiply. Under the radicals get to combine. Outside the radicals get to combine. But I can't go putting the 3 and 8 together or the 8 and 2 together. The 8 is outside, he stays outside. The root 2, root 3 get to join together. So this next one, the 7 would be alone. And this guy would be a 96. I think I would have rather broken him down earlier. Do the best you can on homework, kiddos. You know that we pick up those last couple examples the next day. So have everything ready except for example 2 and number 3. Sound good? Yeah. Awesome. If you need something, come find me. I would love to help you guys. You did a great job today of being attentive. At least for the most part. Please don't fall asleep. Bye guys. Good job. Good job. Good job, kids.